I know I didn't give you a lot of time there and the off sites to work on these, but hopefully you got through the first one. Let's take a look at this one. This is basically an order of operations problem. We look at the parentheses. Anytime we see a parentheses, again, it should draw our attention there first. So we've got this first parenthesis right here. That one, we have to ask, is there anything we can do inside that parentheses? The answer is no. There's nothing we can do inside there. So then the second thing we have to ask, is there anything that needs to be done to the parentheses? And there is. It's multiplied by 7x. So we have to multiply that whole parentheses by 7x. So 7x times 5x is 35x squared. Perfect. X times x is x squared. Then we have 7x times our negative 7. Which is negative 49x. 7 times negative 7 is negative 49. Then there's nothing to multiply the x, so it's just x. Over here now, it is a negative 3 that multiplies that parentheses. We should go through again. There's nothing we can do inside of it, so we have to see what we can do to that parentheses. So it's negative 3 multiplying it. Negative 3 times 4x is negative 12x. And negative 3 times negative 9 is a positive 27. Are we done? Say no.
No.
No, we're not. Because we have negative 49x and negative 12x. They're both x's. They have the same name. So those can be combined. So the 35x squared has nothing to combine with. Negative 49x and negative 12x. Negative 49, negative 12 go the same direction. It's a negative 61x. And then we have the 27. How many of you had 35x squared minus 61x plus 27? A few of you? Okay. That's a start. Okay. How many of you would have had it if I'd given you more time? Anybody have major questions on how we got there? Okay. The second problem here is a similar task. We have parentheses again, so it draws us in. Is there anything we can do inside those parentheses? Okay, no, there's not. Anything needs to be done to the parentheses? Yes, it's being multiplied by what? A negative 3x to the third. So we have negative 3x to the third times 6x squared. What does that give us? Perfect. Negative 18x to the fifth. You add the powers when you multiply the variables with exponents. So we have negative 3x to the third times a negative 7x. Negative times a negative is positive. 3 times 7, 21. X to the third times x. X to the fourth. Good. We think of that as x to the 1. 3 plus 1 is 4. So what we've done is we've used up this piece in here. Everything else is still there. So we still have the 5x to the fifth up front here. And we still have the positive 2x to the fourth on the back end. Are we done? No, we have things that have the same name. We have x to the fifth and x to the fifth. We should be able to combine those. 5 and negative 18 make positive 5. Negative 18 is going to be negative 13. X to the... When we add or subtract, we keep the same name. So it stays x to the fifth. Then we got x to the fourth and x to the fourth. Positive 21 and positive 2 make positive 23. X to the... It stays the fourth yet. So negative 13x to the fifth plus 23x to the fourth. Looking familiar? Okay. So that was just a little bit of a review of our working with the variables. And you remember one of the other things we did was we worked with phrases like 8 times a number increased by 5. What did we do with that? What did that become? 8 times the number increased by 5. Yeah. 8 times the number will be 8x, or 8 times x. Increased by means we add 5, so plus 5. Well, what if I add a little statement to this? Is 37. How does that change what we're doing here? Yeah, it doesn't change this part at all. It just means we have equals 37. So it's now an equation instead of just an expression. In just a minute, we're going to look and see that there's stuff we can do with that now. So we might have 12 more than twice a number is 24. Okay, yeah, 12 more than twice a number. 12 more means we're going to add 12 to something. Twice a number is 2x or 2n or whatever variable we want to use. And then the is 24 just equals 24. So we're just adding that little bit of an extra dimension to it. So now that we have, we've been able to work with our variables, we can combine variables, we can take words and put them into expressions and now equations. It's time to look at those equations, things that look like this. Working with these, it's vital that we understand what that symbol means, the equal sign. What does it mean? Kind of hard to put in words because hard to define it without using the word equals, isn't it? What it means is that whatever's on one side of it has exactly the same value as what's on the other side. In fact, we can think of it as being a balanced scale. What's on one side exactly balances the other side. All equations start out just like this, as a variable equals a number, and they're built up from there. So some things we can do to build up onto this to make it more complex, we might add to it. Maybe we'll add 5. So x becomes x plus 5. We added 5 to it. Now because this is a balanced scale, if I add 5 to one side, it's going to tip unless I do what? I add 5 to the other side, right? I have to do exactly the same thing to both sides so that it doesn't tip. What's 7 plus 5? 12. I just built onto this equation and made it more complex. This equation here, x plus 5 equals 12, is the exact same equation, x equals 7. I've just built pieces onto it. Well, normally we're not going to build equations. Normally what we're going to be asked to do is solve an equation. And when we are given that command or that request, however you want to put it, to solve an equation, what it's asking us to do is to take the equation back apart and get it back to this form as a variable equals a number. What was done to build this equation here? We added 5, right? So to take it apart, what are we going to do? Subtract 5. We subtract 5, it takes that piece off, and we're left with x. Now again, it's a balanced scale. So to keep that scale balanced, we have to do the exact same thing to both sides. We subtracted 5 over here. We'll subtract 5 over here. What's 12 minus 5? 7. So we get x equals 7. That's exactly where we started. So we just solved that equation. Now for this equation here, we built it. So we knew how it was built. So we knew what needed to be done to take it apart. The difficult part of solving equations is looking at the equation and figuring out how it was built. To do that, I'll take you through the process. First thing we have to do is find the equal sign. Right there is my equal sign. Then we need to identify which side the variable is on. In this equation, the variable's over here. Next, we need to figure out what is keeping the variable from being by itself. Here it's the 2. And the 2 is attached with an operation. It was built on, it was subtracted is how it was attached to it. So how do we take it apart? This was built by subtracting 2. We take it apart by adding 2. Again, making sure we do the exact same thing to both sides of the equal sign to make sure it stays balanced. So here we have y. 13 plus 2 is 15. Y equals 15. Now, if we get to this point, we've solved it. We have variable equals a number, or number equals a variable, same thing. If we're not sure of ourselves, we can always double check our answer by going back to the original equation. But instead of putting the y in there, I'm going to replace y with the number 15. So instead of 13 equals y minus 2, I'm putting in 13 equals 15 minus 2. What is 15 minus 2? 13. So this equation is true. I have the same value on each side. So that proves to me that that answer was correct, that y does have to be 15, because that makes the same value on each side of my equation. So what if I have 7z equals 28? So I find my equal sign right there. Identify where my variable is. What's keeping z from being alone? 7. What operation was used to build it on? It was multiplied, so to get rid of it, we're going to divide. So I divide by 7, makes the 7 go away. I have to divide the other side by 7 to keep my scale balanced. So 28 divided by 7 is 4. Z equals 4. Doesn't stay that simple. Can't add today. There we go. Sorry about that. We look at an equation like this. We're going to do the same thing. Here's my equal sign. There's where my variable is. Now there are two pieces keeping my variable, my x in this case, from being alone. There's a 3 and there's a 2. What operation was used to attach the 3? Multiplication. How about the 2? Addition. It was added. So now I have to ask myself, when this was built then, what was done to my variable? What was done to x? Well, it was multiplied by 3 and 2 was added to it. Order of operations says we do what first? Do we multiply first or do we add? We multiply. So when this was built, x had to be multiplied by the 3 first, and then the 2 was added to it. When we're solving this, however, remember we are taking it apart. If you put something together, whether you put together a piece of furniture or a model or anything, if you've just finished putting it together, you just put on that last piece. If you go to take it apart, what's going to be the first piece you take off? The last one you put on. So when we take this apart, we have to take off the last piece first. Adding 2 is the last piece put on. That's the first piece we have to take off. It was added, so we're going to take it off by subtracting it. That's gone, leaving us with 3x. We have to make sure we subtract it from the other side as well. 32 minus 2 is 30. Now we just have to get rid of the 3. The 3 is multiplied, so we will divide by 3. Again, making sure we divide the other side by 3. 30 divided by 3 is 10. So we get x equals 10. If we're not sure, we go back to our original equation here. 3x becomes 3 times 10 plus 2. Does that equal 32? Well, 3 times 10 is 30. Plus 2 is 32. So we have the same value on both sides of the equation. Any questions? Okay. So how about this one here? We look at how this was built. Again, here's our equal sign. There's our variable. X was multiplied by 7, and then 5 was subtracted from it. So how are we going to solve it? Yep, so it was 5 was on by subtraction, so we're going to add 5 to get rid of it. So 16 plus 5 is 21. All that's left here is 7x. And then divide by 7. So 7's gone, we just have x there. 21 divided by 7 is 3. In your notes, 5x minus 3 equals 27. Try to solve that quick. What's my first step? Add the 3, get rid of the minus 3. So 5x equals 30. And then divide by 5. X equals 6. How many of you had x equals 6? Good deal, almost a clean sweep. Perfect. What's different about this one? We see that the x appears twice. But we find our equal sign right here, and we see that both x's are on the same side of the equal sign. So we're sticking to that idea of a balanced scale. Here, the 3x and 4x are on the same side of that scale. Can I just push them together to make one big pile? Will that change how this balances? No, it won't. 3x and 4x make 7x. Still have the plus 2 equals 30. That will not change a thing. So now we subtract 2 just like we would any other equation. 7x equals 28. And finally, divide by 7. X equals 4. Now once again, if we're not sure of that answer, we can go back and we can rewrite this equation replacing x with 4. So 3x becomes 3 times 4, plus 2 plus 4x becomes 4 times 4. Then we have to check to see if that equals out to 30. 3 times 4 is 12. Do the 4 times 4 is 16. Now we're going to add and subtract from left to right. 12 plus 12 is 14. Plus 16 is 30. And 30 does equal 30, so we're good. In your notes, try to solve that one quick. So what's our first step? We combine the y's. 8y and negative 3y combine to make what? 5y. Good. We still have the positive 2 there. And it's 42 over here. Now what? Subtract the 2. 40 equals 5y. And then divided by 5. 40 divided by 5 is 8. So 8 equals y, or y equals 8. Any questions? So let's have 5x minus 7 equals 2x plus 8. Looking at this one, we again see that the variable appears twice. What's different about this one, though? Yeah, they're not on the same side. It's one on each side. 5x on this side, 2x on that side. So I'm thinking of that balanced scale again. Can I push the 2x and 5x together and make one big pile? No, because they're not on the same side of the scale. So I cannot combine them and put them together. So what I have to do, I can only solve equations that have the variable in them once. So in order to solve this, I have to get rid of one of those. To do that, I'm just going to grab the smaller one and take it off. The smaller one being the 2x. Well, mathematically, how do I take something off? We subtract it. So I'm going to subtract 2x. It is now gone. On this side, I'm left with 8. On this side, I still have to subtract 2x. Cannot take it away from negative 7. The only place I can subtract 2x from is something with the same name, 5x. So 5x minus 2x is 3x. I do still have the negative 7 there. And now it's an equation I know how to solve. What do I do next? Add 7, good. So 3x equals 15. And then divide by 3. X equals 5. And again, I could go back and put 5 in for x and see if it works. So 5x becomes 5 times 5 minus 7 equals 2x becomes 2 times 5 plus 8. So I'm going to do this side. 5 times 5 is 25 minus 7 is 18. This side, 2 times 5 is 10 plus 8 is 18. I get the same value on both sides. Questions? In your notes, try to solve that one. 5x plus 19 equals 7x minus 3. So we have the variables on each side again. We have to get rid of one of them. The question, as always, is which one? Generally, we can get rid of either one, but generally we go after the smallest one. Which one's the smaller one here? The 5x. So I'm going to get rid of it. It's a positive 5x, so I'm going to subtract 5x to make it go away. Leaves me with 19 on that side. I have to take 5x from the other side as well. The only place I can do that is from the 7x. 7x minus 5x is 2x. We still have the minus 3 there. Solving this, what do I do next? Add 3. So 22 equals 2x. And then by 2. 11 equals x. How many of you had 11 equals x? Good. Cruising right along. Okay, so we can solve these equations. Now, and we can write these equations from a situation. So the next step is, let's combine those skills. If I tell you that 5 times a number increased by 11 is 51. Find the number. All that's asking me to do is write the equation and then solve it. So the equation here, 5 times the number is 5x. Could be 5y, 5z, 5n, whatever variable you want to use. Increased by 11 means add 11 is 51 equals 51. That's our equation. Now we can solve. What do we do first? Subtract 11. So 5x equals 40. And then divide by 5. 40 divided by 5 is 8. X equals 8. Find the number. 4 less than 3 times the number is 11. Find the number. In your notes, do that quick. I'll pause for a minute. So, what's our equation going to be? Perfect. 3x minus 4 equals 11. A lot of people get confused by this 4 less than. They think that means you got to start with 4. No, 4 less than means the 4 is being subtracted from something. What's it being subtracted from? Usually it's from what comes right after it. The 3x, 3 times the number. So now we got to solve this by heading for 3x equals 15, and then what do you think? Not terrible. Well, these can become a little bit more practical than just these word sentences. To keep it easier here, we'll look at formulas. Certain things have set formulas that we use. For example, let's look at the perimeter of a rectangle. Perimeter of a rectangle is 2 times the length plus 2 times the width. So if we are told a rectangle that is 4 inches wide has a perimeter of 28. Find the length. Now in this case, we have a set formula that governs these problems. So we're just going to take that formula and plug in values. Do we know P? Yeah, P is the perimeter. That's 28. So I'm going to put 28 in for P. Equals 2 times L. Do we know L? No, the length is L. That's what we're looking for. Plus 2 times W. Do we know W? Yeah, the width is 4 inches. So 2 times W becomes 2 times 4. Now to solve this one, we got a little bit of work to do. Before this is in a form that we can solve, we have to multiply the 2 times 4 to get 8. Good. Now this looks just like a lot of the other equations we've solved. What do we have to do first? Subtract 8. So 28 minus 8 is 20. Over here, the 8's gone. We have just 2L. And then divide by 2. So L equals 10. What do you think? Not so bad?
You kind of fall back into it.
Yeah. If it's something you've done before, it just takes a little while, and then you get back into it. If you haven't seen it before, it'll take a little bit longer to get used to it. Or we might have a formula of profit is equal to total sales minus total cost. So we have an item costs $7 and sells for $18. How many need to be sold to have for a gross profit of $253? I said gross profit. The only reason I added that word gross is that means we don't have to worry about labor and overhead and all that stuff. We're just looking at what it costs to buy it and what we get from selling it. Well, what are we looking for here? We're looking for how many are sold. In our formula, do we know the gross profit? Yeah, we know $253 is our gross profit. Do we know the total sales? No. What we know about sales is they sell for $18 each. The total would be the price, $18, times the number sold. We're looking for how many are sold. So we'll let that be X. The price we sell them for times the number sold is just 18X. Next, our formula is subtract. Do we know the total cost? We don't know it, but we can write an expression for it, right? The total cost is the cost times the number that we sold, right? $7 each. That better be X as well. We had to buy just as many as we sold. So now looking at this, what do we do? Combine 18X and negative 7X, or 18X minus 7X is what? 11X. So 253 equals 11X. And then divide by 11. So 23 equals X. That means they had to sell 23 items to get a gross profit of $253. One for you guys to try. A rectangle that is 15 feet long has a perimeter of 48 feet. Find the width. Do that in your notes. We'll talk about it in a minute. So we have our formula. Perimeter equals 2 times the length plus 2 times the width. Do we know P? What is it? 48. 2 times, do we know L? Is 15. So 2L becomes 2 times 15 plus 2 times W, 2W. Do we know W? No, so that's just going to stay as 2W. What do we have to do next? Combine the 2 times 15, which is 30. So 48 equals 30 plus 2w. And then subtract 30. So 18 equals 2w. And then divide by 2. 9 equals w. So the width is 9. Okay, we're a couple minutes early here, but let's go ahead and take our break. We'll come back at 4:28.